Good morning to you.
Good morning, sir.
Good
Morning,
morning,
sir.
sir.
So, are you looking the subject matters in your computer?
Yes, sir.
The class? Yes, okay. So, in last class, we had done something. Hmm. We had done all these things. Mu is equal to 0.87 Fy ast d minus 1 minus Fy ast fck bd. Okay. So, this expression is available in code also. So, not to worry. Now, we will have to do some permutation and combination for getting different expressions, so that for different information we will be able to utilize these expressions. Now here you see, so we got here mu1 is equal to 0.87 Fy ast d bracket 1 minus Fy ast by fck bd. Now this expression I again bring here. Okay, mu1 is equal to 0.87 ast d. Okay, so this something what we had done manipulated. So see here, ultimately we had got one expression MUR by BD square is equal to 0.87 Fy P by 100 1 minus Fy FCK into P by 100. Now this expression, where we will utilize this expression, this expression rarely we will utilize in our academic purpose. Right. So this expression we will utilize when we go for commercial purpose. Now see left hand side MUR BD square, and right hand side if you see, in right hand side if you see, it is related to Fy, FCK and P. Okay. Now Fy, FCK we can assume ourselves. Say FCK, our as per code, if it is a structural member, FCK, value of FCK should be taken above M25. But if it is a light structure, small structure, say two-storied or three-storied building, then we can utilize M20 also. Okay, so if we know the grade of the concrete, so once we know the grade of concrete, so FCK is known to us. Similarly, we will utilize the steel, whether Fe250, Fe415, Fe500. In normal case, Fe250 is nowadays not at all utilized. It is mild steel, stress is less. So if we utilize Fe250, then we will be required to utilize more amount of steel. But if we go for slightly higher grade of steel, Fe415, see yield stress is 250 Newton per millimeter square for Fe250. For Fe415, yield stress is 415. So it is nearly 60% more. So definitely amount of steel required if we utilize Fe415 in place of Fe250, our amount of steel will be less, nearly 50%. Okay, disadvantage. So we know Fy and FCK. So unknown is P. Unknown is P. Now out of this, MUR is known to us. If MUR is known to us, then B and D also known to us. Why? So when we are calculating MUR, MUR is equal to MU. MUR is equal to MU. MU is the factored bending moment, and MUR is the factored moment of resistance. Now for equilibrium, moment of resistance is internal, bending moment is external. For equilibrium, external bending moment must be equal to internal moment of resistance. Okay, since the expression we are going for amount of steel or cross section, so here in this expression, if we go for this expression, this MUR, B and D are known to us, so we will be able to find out P, percentage of steel. Now this where from we will be able to find, so it is having some in any RCC BIS, it is called SP20. Now SP20 will not be allowed to utilize in your student life. You will be able to utilize as a practice, but in examination it will not be used. It will be permitted to utilize in professional life. So from that table, with respect to particular grade of concrete and particular grade of steel, we'll be able to find out amount of percentage of steel. So percentage of steel, once you know the percentage of steel, hmm, so percentage of steel multiplied by BD divided by 100 will be the total amount of steel required. So for that, this expression is required. Now see here, again, there is a combination for getting XU by D. XU by D. XU by D means actual effective depth factor. XU is the actual effective depth we had already defined beforehand. One is XU, another is XU maximum. XU, as I told you, if you remember, XU is actual neutral axis depth. That means because of the external load, etc., what is the actual neutral axis depth? Because of change of external load, your actual neutral axis will change. If as you are increasing the load, as you are increasing the load, your XU will increase. Okay, but XU maximum is a fixed. Is a fixed that I gave you one table also. Say XU maximum, XU maximum or XU limited. That is the critical neutral axis depth, limiting neutral axis depth, or balanced neutral axis depth. That is a fixed value. That is a fixed value for a particular cross section, for a particular grade of steel, and for a particular grade of concrete. Okay, I gave you one table. XU by D is equal to say 0.5 or if your grade of steel is Fe250, and if it is Fe415, then 0.48, and if it is 500, it is 0.33. Yeah, it is available in your note itself. Oh, sorry, 0.46. If it is 500, it's 0.46. Okay, so this is a constant. So from this, we will be able to find out this. Now this will be required to compare when we will solve the problem that will. Now here we are taking the expression with respect to compression zone or concrete. Our actual expression was this we had calculated somewhere beforehand. Okay, this probably where from it comes. I am not writing. So this I am talking you. 0.36 FCK BD squared XU by D 1 minus 0.42 XU by D. Actually, this expression was 0.36 FCK B into XU. B into XU. 0.36 FCK B into XU. Bracket D minus 0.42 XU. Right? So this square is coming from where? Now from the bracket, D minus 0.42 XU. What you do, you bring out D outside. So once you bring out D from outside, in place of D, it will be just 1, and in place of XU, it will be XU by D. Okay, then in outside there is one only XU. So this D coming out from bracket and for this it becomes D square. Okay, so we got one expression 0.36 FCK BD squared XU by D 1 minus 0.42 XU by D MU, right? Now this. So I don't think explanation for this is required. This is simple mathematical interpretation. So it is very easy. It is very easy. Now see, it is 0.42. So ultimately what happened, it is xu by d, 1 minus 0.42 xu is equal to mu divided by 0.36 fckbd square. That means this part, if you are looking to your laptop, you divide these both left and right side by this part, by this part. So this part on left side it will go, and on right side, so this comes. Now it is simple equation. Now see, so it is 0.42 xu by d into xu by d, so xu by d whole square minus xu by d, x this multiplied by 1 xu by d. So this is brought on this side, so this is a quadratic equation. It's a quadratic one. Ax square, ax square plus bx plus c. A is 0.42, x is xu by d, ax square plus bx, b is xu by d, where b is 1 and x is xu by d plus c is mu by 0.36 fck bd square is equal to 0. So from this we are getting some part I have not written. Probably you will be able to find out it. You'll be able to find out. So ultimately we got one expression xu by d is equal to 1 minus 1.2 minus bracket under root 1.44 minus 6.69 mu by fck bd square. Do you feel that this bracket is required? Anyone? This bracket is required, or without bracket we can solve it? Okay. So from this, what is happening? We are getting xu by d. We had got one expression xu maximum by d. For xu maximum by d, for a particular grade of concrete, the value is there. Say if it is Fe415, Fe415, it is 0.48. Now come here. This xu by d, actual xu by d, how much it is? How much it is? And this will be required to compare with xu maximum by d. See, using expression 0.87 FYAST d minus 0.42, this is mu AST can be calculated, right? Now see here, the interesting informations are coming. Limiting moment of resistance considering compression zone. Now, basic expression mu is equal to 0.36 fck xu d minus 0.42 xu. But when we go for limiting, then xu will be replaced by xu maximum. Simply in that expression, you replace xu by xu maximum. So MUR maximum is equal to MU limit is equal to 0.36 FCK B into XU maximum bracket D minus 0.42 XU maximum. Okay, now do some permutation combination. Okay, you bring out D from the bracket. So when you are bringing D, okay, so see I am writing 0.36 FCK B. Okay, another D is written. That D is written because XU maximum is divided by D. So it neutralized. Then bracket 1 minus 0.42 XU maximum by D. 1 D is outside. This D is removed outside. Okay, so in place of XU maximum, it is coming XU maximum by D. Now this is ultimately what happened, 0.36 FCK BD square XU maximum by D 1 minus 0.42 XU maximum. Okay, so this expression here it was only B, right? This expression can be converted to this. Now see here regular informations. XU maximum by D, depending on grade of steel. Depending on grade of steel, we will be able to get it. Now see here, 0.36 FCK BD square. This part here, XU maximum by D, it is FE 250. So in place of XU maximum by D, we have to place 0.53. We have to place 0.53, right? And here also we have to place 0.53. So ultimately we will get this expression. And similarly for 415.138 FCKBD square for FE5 and this. Okay. So these three expressions are moment of resistance at maximum or critical moment or limiting moment, right? Similar expression we had got, we will get later. We had not got it up till now. We will get. So with respect to still, we are getting expression. Okay, limiting now coming limiting moment of resistance considering still. Now these three expressions, 0.148 FCK BD square, 0.138 FCK BD square, 0.133 FCK BD square. These are with respect to concrete. How we will be able to identify this with respect to concrete? Because in this expression, the factor FCK is available. We will be able to change only the FCK. Say for Fe415. So this we had fixed it. Now we can change the value of concrete. Say M20, M25, M30, and so on. As we are sending M20, M25, M30, so this value we will have to place here. Okay, so by this way we will be able to do this. So this is with respect to concrete. Now 0.87 FYASD D minus 0.4 to XU maximum. Right now here again D is taken out. D is taken out. Here D is taken out. When D is taken out, so one D is here and one D comes here. Right now you see similar thing in previous expression also. See, similar. This part is similar. Whether it is with respect to concrete or with respect to steel, it is similar. Okay, so this. So now question is coming. So these expressions, it is not very difficult to remember. It is very easy. Okay, using this expression, we will be able to find out the critical moment of resistance. Now, what is critical moment? What is the critical moment of resistance? Now here, XU by D, and previous expression was XU maximum by D. So definitely XU maximum is greater than X. Definitely XU maximum is greater than XU. So XU maximum by D must be greater than XU by D. Now XU maximum is the critical neutral axis depth. Critical neutral axis depth. That's why a moment with respect to that is the critical moment. Now if XU goes beyond that, the internal moment induced is going to be more than external moment. It's going to be more than external mode. Okay, so the complication will arise. What complication will arise? We'll discuss slightly later. Only thing that if neutral axis goes beyond this, what is going to happen? Now try to see the strain diagram. In strain diagram, the value 0.0035 at the upper surface will remain same. It will not change. Providing higher quantity of steel. So if we are providing higher quantity of steel than our requirement, then it is over. So in that case, it will be called over reinforced. Okay. So it is not difficult, very simple. Okay. So up to this weekend, whatever we had discussed, this problem. First condition is if XU happens to be XU maximum, then we will be required to redesign the section. Second point, we will consider XU is equal to XU maximum. It means we are considering the section as critical section. These two conditions. Now let us see what is other things. So here you will get some consideration because some arguments. In this case, strain in steel is less than limiting strain. Strain in steel is less than limiting strain. Okay. Now, why you see here in this figure, this is the strain line. This is the strain line. If this is the strain line, this drawing I had done with respect to equilibrium condition. But if the stress, if the amount of steel is more, XU is greater than XU is greater than from here to with respect to this figure, it is XU. Now, if this XU say comes up to here, that means the value of XU comes up to here. Okay. Now this point is fixed. Now, if you draw a line, ultimately this point will come up to this point. That means strain in steel is not reaching its actual value. Okay, so from this figure we can see it. Now under that situation, what is happening? Let us see. Now what is that? Strain under this section, XU is equal to 0.87 FYAST divided by 0.6 FCKB may not give correct value. This expression we will utilize for calculating XU. XU, because AST is known, B is known, so we will be able to find out XU. Okay, what is said now from argument point of view may not be correct. So under that situation, under this condition, to locate the true location of neutral axis and error method, trial and error method must be. Now for this, there is no direct method, direct mathematical mathematics. Direct mathematics. So you know in different subjects, even in your secondary level, when there is no proper mathematical expression, proper mathematical expression for solution of the problem, what is done? Trial and error method. That means there may be two unknown, we know the limit. We know the limit for both. So you, for one unknown, you assume some value, you find out the unknown. Now compare with its restriction. So by this way, two or three, after 2, 3, 4 trials, we'll be able to come to the conclusion. We'll be able to come to the conclusion. So this is the method. So what is done? These steps given: assume a suitable initial trial value of XU. Okay, where from? Where from? So that trial value, whatever value we are getting with respect to this expression, with respect to this expression, XU is equal to 0.87 FYAST divided by 0.36 FCKB. B. So whatever value we got, assume that is the correct value. Determine epsilon ST by considering compatibility equation. So this equation we had obtained from our strain diagram, from this diagram. This is D XU 0.0035. From this figure, this is the obtained epsilon ST is equal to 0.0 at the extreme top 0.0035 bracket D minus XU. After simplification, we will be able to find out. So epsilon ST is known as determine the design stress FST corresponding to epsilon ST as above in step 2 from the. So this curve, it is available in IS 456, also in your textbook. So we know this curve is with respect to the stress strain curve. It is the stress strain curve. So approximate strain we got. Now with respect to this approximate strain epsilon ST from that curve, we will be able to find out the FST, stress in steel. Okay. Now, to derive the value of XU corresponding to FST obtained in this step 3 by considering TA is equal to FST into AST. So FST is known. So we can find out total tension. AST is already we are having. So we will be able to find out AST. Now taking this value of AST and FST, again find out XU. It will change. It will change. So that's why I did that. Compare this value of XU with the value of the first. If difference of the value is acceptably small, and accept the value of step 4. Otherwise, repeat step 4. That I told you very beginning. There are two unknowns. Now, for these two unknowns, if we want to solve mathematically, we require two equations. Again, to frame the equation, it may be a complicated situation. And that part is for people of mathematics. But for us, we require some result. So what will we do? We have some equation. So what we'll do? We'll consider one value. We'll try to find out the other. Whether it approaches or goes by to the permissible. If it is not permissible, repeat. Ultimately, it will come to closer. You will not get actual value. You will not get actual value, but it will come very closer. That closer value, with respect to the last assumed value, will be our required value. So ultimately, we will be able to find out all these things. Right? See, there are some values. These are from the textbook. Whether you will be able to remember it or not. Anyone? Yes or no? Are you listening? Are you hearing me? Or you are not hearing me? You are hearing? You are getting my voice?
Yes,
Yes,
sir.
sir.
Yes, yes. Now this table,
Yes, sir.
this table you not necessary to worry. If some values are required, if some values are required from examination point of view, normally these values are given. Otherwise, what I told you, you will be able to find out this value from this figure 23 IS 456, because IS 456 will be allowed in your examination, whether it will be in online or it will be on classroom. Do you expect your next examination to be in your classroom?
Online.
It will be. Are you interested to appear your examination in classroom?
No, sir.
No,
No,
sir. Online.
no, online. Huh? But if situation comes to the better way, then if you appear in online, that means we will never be able to see you. Huh? We will never be able to see you. Okay, let us hope that the environment will come to normal situation, and that situation you will be able to come to it. Okay?
Yes.
This repetition comes. Okay, let it be. That means, okay, your theoretical part, your theoretical part completes. Hmm? It is just repetition because something I entered and say the problems are very easy. Huh? Do you open the class note in your mobile or laptop? No, no, or yes? Now see, this is the problem. The effective cross-section of a single reinforced concrete beam is 300 by 400. The beam is reinforced by, now this is a symbol. This represents three numbers, 12 millimeter Tor steel. This phi represents Tor, T-O-R, Tor steel. There are three numbers, diameter is 12. If M20 concrete, this Fe415 need not write, is used to determine the moment of resistance of the section. Okay. Now see here, which expression will be required to use that we should be able to identify, right? Now see here, we know B, we know D, we know FCK, we know FSD, and we know AST. Now AST I had calculated directly. Okay, you need not, because you are student of fifth semester, you need not find out the area cross section of circular section pi by 4 d square. You try to remember. We will normally utilize in our civil engineering work the diameter of rod 6 millimeter, 8 millimeter, diameter 10 millimeter, 12 millimeter, 16 millimeter, 20 millimeter, 25 millimeter, 32 millimeter. Now cross-sectional area of 20 millimeter, sorry, 6 millimeter diameter is 28 millimeter square. Cross-sectional area of 8 millimeter diameter rod is 50 millimeter square. Cross-sectional area of 10 millimeter diameter is 78.5 millimeter square. Cross-sectional area of 12 millimeter diameter bar is 113 millimeter square. Cross-sectional area of 16 millimeter diameter is 200 millimeter square. Similarly, for 20 diameter is 314. 25 millimeter is 492. Okay, so if you remember, then you will be able to save the time. So AST is known. Okay, so how to solve this so easily? So we know our total compression C, total compression C is a 0.36 FCK B into XU, and total tension steel is 0.87 FY AST. Okay, now in these two expressions, what is unknown? So we can write 0.36 FCK B into XU, total compression, is equal to 0.87 FY AST, total tension. Total compression is equal to total tension that we had discussed. Now here our unknown is XU. So XU is equal to 0.87 FY AST divided by 0.36 K B. So from this we had got actual neutral axis depth is 56.7. Now here you see I am not writing any dimension. I am not writing any dimension. Okay, but this calculation, if you send to any place of the world, everybody will accept, because this we had solved by SI system. SI system. When we are writing SI system, that means your unit will be always Newton and millimeters. If you are utilizing Newton for mass, then for linear measurement, for length measurement millimeter, so you need not write any unit. Okay, so this represents that 56.7. So critical neutral axis, this is having, we are having XU maximum is equal to 0.48 D. Okay, it is 192. Now XU is less than XU maximum. XU is less than XU maximum. Now what this represents? XU, now this expression you had utilized when you had tried, you had learned the bending stress distribution. Bending stress distribution. Okay, so XU is less than XU maximum. So it is above the critical neutral axis. So if it is above the critical neutral axis, that means strain in concrete is not reaching the limiting value. Is not limiting value. And similarly, strain in concrete also not limiting value. So that's why we are giving a statement. That's why we are giving a statement. XU is less than XU maximum. So it is under reinforced concrete, under reinforced section. Under reinforced section. So if it is under reinforced section, so strain in steel attains the value earlier. Strain in concrete does not change. Okay, so if that is the situation, then our moment of resistance with respect to concrete, this expression we had 0.36 FCK BXU D minus 0.42 XU. Then we will be required to utilize the axial neutral axis that factor. So this we got 0.36 into 20 into 300 into 56.7 into bracket 400 minus 0.42 this. Okay, ultimately we had got 46.07 kilonewton meter. Now we have to see same moment of resistance should be obtained utilizing the tension zone also. This we had obtained from compression zone. Same, so we should be able to get from compression tension zone also. So this is 0.87 FY AST D minus 42. So ultimately see same value we got. So solution of the problem is very easy. Solution of the problem is very easy. Okay. Here you will get several problems. Only problem number 2 is exactly similar, only values are sensed. Only the values are sensed. Okay. Then you see problem number, next problem. Next problem. Again, same, the same, only values are sensed. Only for us, this